Hi everyone. Thank you for taking the time to join us today. We're here to talk about two things. Firstly, the MR game Battlenauts that we made, and also how we brought it to the MetaQuest store using Meta SDKs in a relatively short time. Before we get into that, we're going to introduce ourselves and the studio and give you a little context on how we got here. So I'm Martin Ashford. I'm the creative director and co-founder with Mark.
Hi, I'm Mark Hogan. I'm the director and lead developer at Popup Asylum.
Mark and I have worked together in the industry since 2010. We both worked at the same agency, producing real-time training and marketing experiences in XR. We made serious games for our day jobs and fun games in our free time, both using Unity, until we made contact with Meta in 2022 to develop as Popup Asylum full-time. Popup Asylum is a small 10-person team based in the UK. We focus on small R&D projects, demos, and vertical slices. And when we can, we build games. We try to focus on making sure we build the right project to solve the problem in front of us, building out mechanics and interactions using proven design standards. And we use clear design language in our 3D art to support the player's understanding of the game worlds we build. And this is supported by writing clean, modular code, ensuring that we can build efficiently and maintain a high standard of quality across our portfolio of work. The studio was founded in 2013 as a hobby project, and in 2022 we began working with Meta as a third-party supplier, releasing demos like First Hand and Move Fast with Meta's Interaction SDK team, then releasing Battlenauts ourselves in late 2024. Battlenauts is a 4-player mixed reality game based on the classic tabletop game Battleship. Set in the near future, where space travel and within the solar system has become possible, and factions battle over control of a newly formed wormhole and access to a new solar system's worth of resources. Players arrange their fleet and then try to locate their opponent's ships by launching missiles at the opposite side of the board. I'll just let that finish. So as a small team that focuses on R&D prototypes to prove out ideas, we end up with a lot of projects that never see the light of day, some more successful than others. One of these prototypes was a 4-player Battleship game in VR, and that was part of a much larger social project. Sometime after putting the project down, we discovered one of Meta's mixed reality sample projects, and we could see the potential for an MR tabletop version of our prototype. We went from an existing VR prototype to a polished MR game with AI bots and single-player campaign in just over 3 months using Meta dev tools. In our social prototype, we wanted to explore compelling social interactions that focused heavily on hand tracking. Our aim was to create a set of hand interactions that felt effortless within the VR social setting. By removing the controller, it allows for better social presence between players, and by building games that are more suited to hand interactions, it lets players interact in a way they intuitively understand, removing the controller learning curve, making games more accessible to everyone. We built a 4-player version of Battleship to highlight pick up and place and button poke interactions, a simple 2-player Hearthstone-style card game to show playing card interactions, and a free-for-all shooter using pinch to fire. We played Meta's Spirit Sling sample project, which is also a 4-player mixed reality tabletop game where players fire slingshots to attack other players' pieces on the board. Spirit Sling demonstrated the potential for an MR tabletop version of our Battleship prototype, and because of the way we built our original prototype, it was simple to combine the 2 projects into a polished released game. Having a successful sample project to reference proved that there was a place for more tabletop MR content on the Quest store, and it was great to see what worked. And that's Spirit Sling. But why build an MR version of Battleship? Tabletop gaming has always been a very social pastime, which brings people together. With the prominence of MR and improvements in Avatar 2.0, digital tabletop gaming is able to capture the same feeling you get from playing games physically together. Organizing a physical games night can be difficult. Even resetting the board can take time. A digital tabletop game, it removes all the stress from setting up a game, and finding players to play with online is easy with public and private game lobbies, and MR doesn't compromise on social presence. Hand tracking, MR, and social presence provide the perfect mix for an engaging and effortless experience for people who are new to XR and veteran players alike. We use all three to capture the essence of a tabletop experience digitally. But it wasn't without its challenges. With mixed reality, there's nothing preventing you from rendering objects at any distance, but placing them further than the player's walls can mess with their sense of depth perception and make the interaction feel unnatural. So it was important to keep the players close enough to each other that everyone appeared inside the player's home environment without compromising gameplay. Our prototype's board layout was designed for a large VR space, much larger than most people will have in pass-through. In order to get the opposite player inside the play space, we needed to scale it down and make it to a more natural tabletop size that aligns with the traditional board games, and some elements needed to be redesigned. We took the flat board from the prototype and made it vertical and transparent. That way players could see each other's boards and retain their eye line with other players while missiles were flying and ships were destroyed. As a fun side effect, when a missile flew towards the board and missed, it would carry on going towards the opponent narrowly missing them, which was kind of fun. Sometimes a player's room might be too small even for this setup. When this was the case, we used a blending trick to fade any objects rendered beyond the player's walls. Meta's mixed reality utility kit can generate a 3D mesh of the player's room. We rendered the room mesh using a multiply blend mode to darken whatever had been removed beyond the room's mesh. When composited with the camera feed, the darkened color of the game allows more of the real world to show through, giving the objects a transparent look. This worked great and didn't require any changes to the existing shaders, including the avatar shader. Our social prototype didn't include single player. We wanted single player to capture the same feeling as multiplayer tabletop game, so we took the time to produce bots with personality and a complete upper body 3D model. We used Marvelous Designer to quickly create a spacesuit using cloth simulation of the 2D garment patterns. Marvelous Designer is really powerful for creating character clothing to a high standard in a short time. For animation, we used Mixamo, a free library of thousands of full-body character animations. The animations were linked to hits, misses, win, and lose states in Unity. We added more animation than we ended up using, but it was great to have options. Bots sometimes ended up displaying more personality than human players. And we hear that from players as well in reviews. Nothing on this side is new at all. But we wanted to touch on art production and maintaining quality across assets quickly and getting art into Unity in a controlled way. We use consistent material IDs in all of our high to low polygon workflow. We create a shared smart material in Substance Painter that is used on all of the assets in the project to keep the visual language consistent between assets. Once inside Unity, we make sure we maintain connections to the imported FBX. If we change something in Maya, it updates nicely in Unity. Everything becomes a prefab, and then those prefabs often end up inside other prefabs, which are then brought back to Maya using Unity's FBX exporter. We then control animations, particles, and audio inside Unity Timeline so that we know animations will play out exactly how we want them to. Mark is now going to explain how we were able to get Battlenauts release ready fast.
Thank you. Okay, so I'm going to cover some of the Meta SDKs that we used in Battlenauts to speed up our development. So that's including the Avatar SDK, Interaction SDK, Audio SDK, Scene API, as well as Meta's Spirit Sling sample project. So Meta released the entire Spirit Sling project as a free open source resource for mixed reality tabletop games as part of their many GitHub samples. And it shows some of the best practices for doing tabletop MR and helped getting the project set up. The Spirit Sling sample is divided into two parts. So it has the game's core logic, which handles the mechanics and rules of Spirit Sling itself. And then aside from that, it has its mixed reality tabletop framework. So the tabletop framework provided all the logic for positioning the board inside of the player's space, as well as handling player and avatar co-presence and networking. And it also provided wrappers for photon fusion, which are integrated with Meta's platform destination API, allowing players to invite their friends on the platform to a game. So that's the Spirit Sling project on GitHub there. Our original prototype ran on Photon Pun, but with the framework, we switched to Photon Fusion, which is one of the go-to networking solutions for Unity. And this meant that we could replace our old lobby and room setup code with the framework's built-in system, which simplified our code base. And our game logic for the prototype was already well structured, so integrating it with the framework was fairly painless. Ship placement, attacks, and turn-based mechanics carried over seamlessly, and that meant that we were able to focus on really refining the experience for mixed reality. Starting with player representation. So player representation is a challenge that all multiplayer games face, and teams can spend tons of time trying to give players opportunities to change how they look. With Battlenauts, it coincided with the release of Avatar 2.0. So using the Avatar SDK, we were able to offload a significant amount of dev time and give players a high-quality representation of themselves that is familiar across other games as well as Horizon worlds. And with Avatar 2.0, we finally got legs, which is great because we didn't have them in Avatar 1.0. But it's very much geared towards standing games. And ours, being a casual seated game, often the avatar's legs in a stood position would go through the floor, and it'd look very weird. And cause depth mismatch, where your eyes are perceiving two things at different depths. So we decided to add seats to the avatars using Avatar SDKs Attachments API, which is great because you can pin any object to the avatar, to the hips for the chairs, but you can also do shoulders. It's kind of designed for weapon systems, really. But we ought to pin the seat model to the avatar's hips, and then that will then scale if the avatar changes sizes. If they've got a larger avatar, it scales the seat for them automatically. Works really well. And we used the avatar animation behavior to pose the avatars in a seated position, as you can see there. And this really added to the board game feel, whilst keeping player eye lines consistent and avoiding the depth mismatch on the legs. And in Battlenauts, Meta's Interaction SDK handles pretty much all the interactions. ISDK has got amazing support for hand tracking with a robust set of interactions like grab and poke. And when you're making a pass-through or mixed reality game, we really recommend going hand first for your inputs because the players can see their hands as it's passed through. We used ISDK's poke interaction to handle most of the board interactions. The default settings worked great out of the box. And we use this for selecting what cell you want to attack on your opponent's board, changing which player you're attacking, because you can attack any of the 4 players you're playing with, as well as the game's various menus and buttons and system interfaces, which work great and worked out of the box with ISDK's Unity UI integration. And when you're using poke with hands, it just feels really natural. It's a really good interaction. And then hand grab is ISDK's solution for grabbing objects. So in Battlenauts, we use that at the start of the game when you want to pick up your pieces and place them on the board. And when you're doing a special attack mid-round. Hand grab is built as a very modular system, and it has great default settings, but thanks to its modularity, you're able to swap out sections of it. So we were able to specialize parts of it for Battlenauts. For example, when you're grabbing the board, we use a two-handed rotation interaction so that the player can't like flip the board upside down. And when you're placing your pieces at the start of the round, we were able to exaggerate the effect of the wrist's rotation to help players when they want to rotate the ship 90 degrees, because it's quite straining to turn your hand the full way. We can exaggerate that, and they only have to make a small movement to place the ships exactly how they want to lay them out. So for the public release, we knew that single-player modes would be expectation, and our prototype had been exclusively multiplayer. So this was a brand new feature. To make this work quickly, we used Photon Fusion's offline single-player mode and made the bots use the same API as the players. Essentially, each bot worked the same way as a human player would in a multiplayer game. The enemy AI uses the same rules and has the same limitations as a player to make every encounter fair, but it also includes behaviors to mimic humans and enhance unpredictability and excitement. So depending on a bot's personality, they might attack a player who's weak, or retaliate against someone who's just attacked them, or challenge the player with the most health. And once we had single-player quick play working, it was simple enough to create a set of these bot personalities with gradually increasing difficulty and choose a number of bots per level to create a campaign that was challenging and added some story context to the world building around the 4 factions. After the player completes the campaign, they earn a score, and this score goes on a leaderboard. And we were also able to save dev time here by letting the Meta Platform API handle the scoreboard. So before I hand back over to Martin, I want to touch on some other tips that save time. So we were able to iterate faster by replacing hand-coded if statement conditions with Interaction SDKs active states. So Interaction SDKs active state is like a Unity serializable interface that can achieve similar functionality to if statements, but it's a lot quicker and you don't need to write any extra code. For example, you can use an active state group to combine multiple active states and trigger some in-game functionality based off of that when all become true. So if mid-game you discover that some buttons shouldn't be interactable when the game is paused, you can disable that by just dragging is pause condition in there, no extra code needed. And we used Meta's XR simulator to quickly test small changes in the editor, which is it's a lightweight XR runtime, and it allowed us to debug and iterate without constantly putting on and taking off the headset and dealing with Oculus Link. It made the daily development a lot smoother, and it paired great with Parallel Sync. So Parallel Sync is an editor extension for multiplayer testing across multiple editors. And by combining the XR simulator with Parallel Sync, we were able to run multiple instances of the game on multiple editors on the same computer. And we were able to do mixed setups as well, so we could have one instance running on the headset via MetaQuest Link, whilst another instance on the same PC is running using the simulator, which is great for multiplayer testing. And on the image there, you can see we've got 2 game instances running Unity in the background. And one of them on the left there is MetaQuest Link, and the other one is using the XR simulator, all on the same PC. Martin?
And finally, good game development is always going to be incredibly hard. To get it right, building a fun and compelling game takes time and energy. We're not saying you can always do that fast. But if you have a winning idea or a prototype that you're looking to find a way to get it into the hands of the players fast, the support is there with Meta's dev tools. Casual tabletop MR is a relatively fresh concept, and now you have the tools you need to make an engaging MR content to a generally higher standard than you would when building those systems yourselves or ourselves. Thanks for listening. So it looks like we've got some time left for QA, if anyone wants Q&A, if anyone's got any questions. I encourage everyone to come up to the mic, though, please.
Hi, thank you very much. It's a great talk, loved it. I was curious about what kind of hand inputs that your players and users might have been doing that you didn't see it coming. Maybe they were trying to perform an action, you knew what they were trying to do, but you didn't think about how they were doing it until you watched like maybe somebody play testing or something like, oh, I see what they were doing, and then you resolved that.
Probably one for you, I think.
So the question's about hand inputs that we weren't expecting the user to do. I think certainly the ship placement exaggeration was one of those where players would be trying. When you're laying out your board in battleships, you want to get what you want to get. So like ISDK's hand grab is mostly based off of wrist rotation, but when you're placing a piece on a board, a lot of the movement or the rotation comes from the very small movements of your fingertips. Like I can turn a ship 90 degrees just with my fingertips in the real game. So I'd say like that was something that we found players were struggling to turn their ships, and so that was one of the ones that we came up with a solution by just exaggerating all this wrist rotation so that we could keep ISDK's wrist-based movement, but the players weren't getting frustrated because they had to really jank their arm around to turn it 90 degrees.
As a follow-up question, did you ever happen to find any value or have any conversations regarding giving the player maybe a setting or a control for them to be able to determine? Because I'm working on a puzzle game in a similar fashion. I want to be able to have blocks rotating. And I've kind of been wondering about that very thing, about having an opportunity for the player to decide for themselves in the settings how much of a hand rotation they want to be able to do to rotate those blocks and pieces.
I mean, we were definitely going for this is like a hidden feature. Like the players, the players when they're turning the pieces, their hands, they are moving, doing these micro gestures with their fingers, and it's the actual. I think it feels to them like they're moving it with their fingers when really they are moving it with their wrists because we've tried to make it very subtle and a sort of a hidden feature to the player.
Cool. Thank you.
Hello. Thank you very much for the talk. It was very insightful and useful. I see you mentioning about Avatars 2.0 in its seated pose and how you used it. Were there any challenges that you faced around that when users would, I don't know, sit and move around or something, or handling animations around seated pose of Avatars?
So the question is about any challenges with the avatar animation system.
Avatar animation system, especially anything with the seated pose with the chair attachments. Yeah,
so I'd say like the Avatar 2.0 is really definitely geared to standing at the moment. So in our game, you're seated regardless to whether you're standing in real life or not, and it works well. Everyone has like a hover chair, and it doesn't feel unnatural. Normally we do play seated, so like. But that was definitely a challenge to get that in because simply how geared the Avatar SDK was at the time to the idea that the players are standing, even to the point of in the version at the time, which I think we would say maybe V69 or 68. If you were seated, your avatar on the network would still be standing, and your eye level would be incorrect. People would be looking up to talk to you, and it was wrong. So we did have to struggle a bit through that, but then with the updates, maybe in 72, they made it a lot easier to customize your animations, and I think it's going to get even easier and easier.
Okay, thank you.
Yeah.
I also think it's incredibly important to note that your own interpretation of what the other avatars, the other players are doing, you should make sure it is clear and consistent and readable. So whether the other player is doing something or even laying down, as long as to you, that they look like they're being represented in a good way, it will encourage them and you to have a good experience together, which is ultimately the end goal. So reality and accuracy is one thing, but consistency and fidelity is probably a nicer goal to try and reach.
Okay, just to like make sure I'm getting the right thing. In this case, all avatars are always sitting, irrespective of the physical position of the other players. Is that right?
Yes, that is correct.
Okay.
You are always sitting to them, and they are always sitting to you.
Got it. Thank you.
Other folks, so you mentioned before a test game you guys were doing that was similar to Hearthstone. Has Meta thought about making a collectible card game?
We are a third-party supplier, so let me repeat the question, sorry. Has Meta thought about making a collectible card game?
Yeah.
As a third-party supplier, we aren't fully aware of what goes on at Meta, but I would say that card interactions are something that, in general, everybody would like to work well in MR, including us. You know, we had a moderate success with our demo. I think it was quite playable and quite fun. I wouldn't know any 100% on anything, but I would encourage everyone to keep an eye on the Interaction SDK team and the work they're doing.
Right.
I'm sure they have some great stuff in the works.
Thank you very much.
Thanks for the talk, guys. What was something that was either surprising or unexpected, like feedback that you got from players, maybe related to it being a mixed reality title?
So the question was surprising feedback from players with it being a mixed reality title. Generally, I'd say our player base is, at the moment, nice. It's a good size. It's manageable. I wouldn't say it's out of our control. We are very lucky to have 4.9 on the store as a paid game, which we're very, very happy about. And generally, everybody just says this is an excellent example of Battleship in MR, and they enjoy playing it. They've also been really, really good and quick to let us know when there are bugs, which we were happy to fix. So nothing surprising, but we're hopeful for, maybe there's some curveballs.
Thanks.
Yeah, thank you for the talk. So I want to talk about how you referenced how you had to change your tabletop design to make it more sort of vertical because of the limited space. So given how AR environments are very arbitrary, people can set up their room however they want. Did you have any special logic for the initial placement of your game assets to make sure that they don't clip into furniture or into the wall or anything?
You want to take this one? Sure. Yeah.
So we used Spirit Sling's tabletop framework for that, and it worked right out of the box. So I'd encourage you to have a look at the Spirit Sling GitHub. The gist of it is MRUK, the Mixed Reality Utility Kit can give you, it has an API to give you, here's a position for something of this size in the room, please give me that. And you can specify tabletop or walls. In ours, we specify a tabletop, and if we don't find a tabletop, we try to position it somewhere in the room that's not intersecting the walls. And if all else fails, we just position it in front of the camera.
Okay. Did you ever have any issues where the initial placement was in the player, so the player started inside the table?
I'd say yes, but we give the player obviously the option to move it themselves, and if it is going to intersect the player, then we'd rather it intersect the wall. So we'll fall back to in front of the camera at that point, and let the player just move it where they want it.
Okay.
And if you're in a room that the player hasn't set up as well, we follow that same logic of in front of you, and it works well.
Got it. Thank you very much.
Hi. Thank you so much for the talk. I was kind of curious, you mentioned the Meta XR simulator, and it was useful for your development. I was curious, how did it help you guys do your work?
So with the, if you've used MetaQuest Link, you can either use it cabled or Wi-Fi, and if you use it on the Wi-Fi, then a few times during the day, you might find it disconnects from the Wi-Fi, and you've got to go through various menus again. So using the XR simulator, It just kind of saves you that trouble, and you've still got a lot of the hand interactions that you would want to do. So like, you know, we're able to test pressing buttons using the keyboard controls and the mouse. And yeah, it's a toggle in Unity to turn it on. So you tap it, hit play, and then it opens up as a fresh window, and you can just test what you want to test very quickly, without bothering to. Oh, link is disconnected again. I need to restart Unity and put the headset back on and launch it again. So like we're using it for that, and then the fact that you can run several instances of the XR simulator all at once, just for multiplayer, that was amazing. I could launch 3 instances of the XR simulator and put on the headset myself, and I could play the game against myself all on one PC. I didn't need to like connect to anyone or bug anybody to say, oh, come on, I need to test something, can you join the game with me? Although that did happen all the time as well. But for most of the time, yeah, if you just need to test something multiplayer, just launch 3 XR simulators and you're good.
Well, I will add to that as a creative director and with the audio team and the art team and design team, it was almost sometimes more stressful knowing that the devs could test without us. Because we were sat there going and wondering, how is this thing coming along? And then they just provide us with a polished, finished product all of a sudden, instead of us all having to test out loads and loads of bugs, which is reassuring. But for this was the first project we really used it for, so it was a little bit of a change of pace for us, not having to test as much in a positive way.
Thank you.
Any more questions? So I'll just leave it on the feedback slide. Thanks again, and if you could please find time to scan the QR code and let us know how we did, we'd really appreciate it. And we'll be hanging around here for a bit, and I think there's a alcove around there, which we will be there for a while if anyone wants to chat. Thank you.